All right, so if we have to linearize this function at x equals 0, as the problem's asking, the first thing we're going to do is we're going to establish a point. If we know that x equals 0, we're going to take 0, we're going to plug back into the function to figure out the location we're working at on this function, to figure out that specific point we're working at on this function. So plugging in 0, now let's see, we're going to have 1 over the square root of 2 plus 0, right? So we're going to have 1 over the square root of 2. Meaning the point we're focusing our attention in on, x is 0, y is 1 over the square root of 2. That's the first thing we're going to do when we're asked to linearize something. Next thing we're going to do, we're going to find a slope. We're going to find the slope of the tangent line at this point. So as we know, to find a slope, we take a derivative. First thing I'm going to do, though, with this function, I'm going to tweak it a little bit. We know with this root, we can raise that as a power of 1/2. We also know, since this is in the denominator, we can bump it up and change that to a negative power. So if I raise it to a power of 1/2, this quantity of 2 plus x, and I bump it up, new power becomes negative 1/2. That way, when I take the derivative, I bring that negative 1/2 down. Got your quantity of 2 plus x. Subtract 1 away from that power, so new power is going to be negative 3/2. And then take the derivative of the inside, because we're applying the chain rule here, right? So the derivative of the inside is just going to be 1. That's my derivative, which gives me my formula for finding a slope at any point. It'd be nice to clean this up a little bit, though, before we find that slope. So, because I have a negative exponent here, because I have a fraction here, we're going to create one great big fraction as our simplified answer. And probably the best way to go through and do this, we know denominator here is 2, so got to be a 2 on the bottom. We know we have this negative exponent here applied to this quantity, so I'm going to take that negative exponent and that quantity, place it back downstairs with a positive power now. As far as what's left on top, well, we got our numerator over here, negative 1. We got this one. Let's multiply that together, get negative 1 on top. So there's the simplified form. And if you want to take it one step further, don't have to do this, but you could. With this fractional exponent, we know the denominator, that's our index number on our root. So we'd be taking the square root of 2 plus x, and numerator is the power that's applied to that, so that'd be cubed, if you want to take it one step further. All right, so we got the simplified form for the derivative. We need to find the slope. So the slope will be found at this particular point by taking 0, our x value, and plugging in to the derivative. So when we plug in, we'll have negative 1 over, it'll be 2 times square root of basically 2, right? All of that cubed, right? Okay, so that's kind of a mess here. Let's see. We're going to have negative 1 over. Whenever we apply this power of 3, right, we can apply it to the square root overall. We can also apply it to just the 2 underneath. So if I apply it to just the 2 underneath, that'd be 2 cubed, right? So that'd be 8. If you take the square root of 8 and you simplify the square root of 8, you guys know what that is? 2 root 2. All right, so this becomes 2 root 2. You're multiplying the 2. You've got negative 1 over, be 4 root 2 as your slope. Okay, so we got a slope. We got a point. Next thing we want to do, we want to find an equation for the tangent line, and we're almost there. We've done all the hard work to find the equation. So using our point slope form like we usually do, we've got y minus the y value that we found. Y value was 1 over root 2. That equals the slope that we just found. That was negative 1 over 4 root 2. And we're multiplying to the quantity x minus the x value at our point, which is 0. And normally, if we're asked to find the equation of a tangent line, that's where we stop. But here, we're asked to linearize. So what we call the linearization, well, the linearization, all we do is we take this equation, solve for y. If you solve for y, you're going to take this negative 1 over root 2, you're going to add it over. So when I add it over, I've got negative 1 over 4 root 2 times the quantity x minus 0, or just times x. And we're adding on 1 over root 2, right? That's the right side here. And that all equals y. But instead of letting that equal y, we're going to make this all official-like. We're going to slap a little function notation on there to show that we've linearized it. I'm going to use the notation L of x to make this all official. So that function represents the linearization.